All right. So we will be taking notes on solving systems by substitution or substitution method, as they call it. Okay. So let's begin. Um, so let's start with the title. Solving systems by substitution. So it's still under the title of system, so we don't need to put anything in the table of contents, but let's just say solving systems and we're just going to call it the substitution method. Ta-da! All right, it's a little okay. So solving system substitution method. Um, and there's really four steps we need to follow. So we're going to be solving equations, systems of equations, in this case, two linear equations, um, algebraically. And this is one of several methods, and this is one that we're going to use. Okay. And the way you would do this is start with step one. Write down step number one, please. All right. And step number one is going to be find or create an equation with a variable by itself. So find or create, and we won't need to create, thank goodness, an equation with a variable by itself. Okay, so that's the first step. Find or create an equation with a variable by itself. All right. Let's move on to step two. Step two. Okay, I'll give you a minute to catch up on that. Let me get one more person in. So I'll give you a moment to catch up writing that. I think in the meantime, I'll highlight this. Okay, Olivia, we're taking notes, so make sure you write these down. All right, step two, substitute what the variable is equal to into the other equation. So it's going to make sense once we start doing this. This is called the substitution step. So it's substitute what the variable is equal to into the other equation. All right. Step number two, write that down. Substitute what the variable is equal to into the other equation. Okay. Moving on. Step three. Step three, solve the new equation for the remaining variable. Solve the new equation for the remaining variable. Okay, that is step 3. So we have one more step to go. All right. So if you've done everything that in these 3 steps, you know one of the 2 variables. And since we use x and y usually, you know what x equals to or y equals to at this point. So now you're going to use that fact to find the other variable's values. So step 4. Step 4. Use your answer from step 3. So we're going to use our answer from step 3. To find the other variable's value. Okay, that's step 4. And at that point, you should know what x equals to and y equals to, and you can write your ordered pair. Okay? All right, so I'll give you a minute to catch up. And we're going to solve 6 systems of equations using this method. Okay? 6 systems of equations using what were the substitution method. Okay? All right. Again, I'm going to post the notes, of course. I always do that. Also, I'm going to have a video of this lecture. I'm doing it right now. And hopefully with any luck, I'll post it up and make it a YouTube video, and then I'll share it with all of you. Okay? All right. So I'm going to move this up just a bit because we're going to start solving some. Okay? So let's do some examples. We're going to solve by substitution. Example 1. All right, let's start with a system. We'll start with an easy one. So let's do y equals 2 times x, and then y equals 7x minus 15. So this is a system of equations. All right, and here's the thing. We got to do that first step. Find or create an equation with a variable by itself. So basically at this point, we have both equations with a variable by itself. I'll show you. This says y equals 2x. Y is by itself. So that equation has a variable by itself. Y equals 7x minus 15. That equation has a variable by itself, the y. The question is, which one would you rather work with? In the chat, type in which one do you feel is easier to work with. And there is a better answer, by the way. It's not one of those, oh, there's no right answer. Yeah, there is. One of these 2 equations is definitely easier to work with. So in the chat, which one do you think is easier to work with? Type it in either y equals 2x or y equals 7x minus 15. I want to see where your instincts are on this. What you feel is easier to work with. And probably what you're thinking is correct. Okay, thank you, Jesse. You are correct. Thank you, Heaven. You are correct. Okay. All right. Ah. Some of you like the harder route. I mean, you can use that one, but it would be more work, and you'll see why. Okay. So many of you are actually picking y equals 7x minus 15, but the one that's actually easier to work with at the beginning for substitution is y equals 2x. Y equals 2x. Okay, so I am going to write that down over here. Y equals 2x. Okay, and the reason is it equals just one term, 2x. So what I'm going to do, I'm going to show my work here. What I'm going to do is I'm going to write down the other equation again. Y equals 7x minus 15. So I can show you the substitution that we're going to do. So what we're going to do is I just rewrote y equals 7x minus 15, our other equation. And you see this y here? Well, I can replace y with whatever I want. And what I want to replace it with is what the other equation equals for y, 2x. That's why we call this substitution. So that is step 2. So basically we did the first step. We found an equation with a variable by itself. And now I'm going to substitute in 2x instead of y into this equation. So I'm going to write that down, 2x. And then write down the rest of the equation equals 7x minus 15. Okay, so now I have 2x equals 7x minus 15. This is called the substitution method step. Okay, so you may be saying, well, that looks a little harder now. Well, here's the thing. I no longer have two variables. Before I had y and x in one equation. Now I just have x in the equation. And I can solve that. Okay? I can figure out what x is. I can solve for this. Remember? I got variables on both sides. If I want to remove, let's say I want to remove the 7x. Remember what I do? Correct. I would subtract 7x. And then I subtract it on the other side, because whatever I do on one side, I do to the other. And that cancels. Okay? And now I can write this down again. 2x take away 7x. Well, that's, you're adding a positive and a negative. This is negative 5x. Equals, that canceled. I still have minus or negative 15. And I can go on to solve this. Divide by negative 5. So now we're just solving equations like we've done most of last semester. Okay? So I canceled. I divided by negative 5. Bring down x. Let me figure out what negative 15 divided by negative 5 is. Okay? And that is positive 3. So I now have an answer here for x. Whatever the solution is, the x part of that solution is positive 3. Okay? So I got to figure out what y is. So here's what I'm going to do. I'm going to write down this equation, that simple equation again, y equals 2x. I'm going to write down the equation I haven't used yet. And I'm going to replace the x portion in that equation with 3. I'm going to use that. Use the answer from step 3, right, to find the other variable's value. So I'm going to rewrite this part. So here I go. Y equals 2 times whatever x is, and I know it's 3. So basically it's y equals 2 times 3. So what is the value for y. Please tell me in the chat. Y equals what? 6. Thank you. I got my answers. X is 3, y is 6. So I didn't need to graph this line or lines. I got the answer by doing a little bit of algebra. My solution is the following. 3, 6. All right. Any questions? All right. I'll give you a minute to kind of process that for a bit, and we'll go on to the next one. All right. So those are all the steps. Okay. So let's go ahead and move on to number... Yeah, the slope. Well, no, if we're talking about slope, the slope would be 2 over 1, and here the slope would be 7 over 1. So the slope, remember, is the number being multiplied with x. That's a very good question. Yeah. Fortunately, since we're not graphing, we don't have to worry about slope. And you're going to see that some of the answers we get, especially like on numbers, I don't know, 3, 4, 5, and 6, they're going to be a little messier. So, okay. Let's do example 2. Example 2. All right, so let's write a system. Excuse me. This time I have x equals 4y plus 3. And x equals 7y. So here's our system that we want to solve. Now, same question as before. Which of these two equations is easier to work with as far as we want to get one that with a variable by itself, and we have 2, but which one would be easier to work with for substitution? Correct. X equals 7y. X equals 7y. We are going to work with that equation. Let me write it down here. X equals 7y. It's just shorter and less stuff to substitute. So what I'm going to do is I'm going to take the other equation, x equals 4y plus 3, right? And I'm going to take what x equals 7y in this equation, and wherever you see the x, we substitute. We replace x with 7y. Okay, so let's do that. Let's substitute in 7y for x. Let me do that. So instead of x, I'm going to write 7y, and then the rest of this equation equals 4y plus 3. Okay? So there it is. Now, I want to solve this. I got variables on both sides of the equation. I'm going to get rid of this 4y. So I'm going to do the opposite, negative 4y. Now do that on the left side as well. Okay? Because 4y and negative 4y cancel. That's gone. And then 7y minus 4y is 3y equals, well, I had 3 here. I just bring it down. All right. So now I got 3y equals 3. Let me divide out by 3. Cancel. And I get y equals 3/3, which is just 1. So I got the value for y this time. I know y equals 1. Okay? So just like that, I got one of the answers. Simple. Okay? Let's figure out the answer for the other equation. So for that, I need, well, I already used x equals 4y plus 3. Let me rewrite this equation over here. X equals 7y. That's going to be a little easier for me to work with. And I'm going to take the fact that y equals 1 and replace y in that equation, substitute a 1 for y. So I get x equals 7 times, not y this time, but what y equals, 1. And I'm going to get my answer for x now. X equals 7 times 1. So what does x have to equal? 7 times 1? 7. Okay. So I have my answer for x. Okay. So let's write down the ordered pair solution. If I were to graph these two lines, okay, where would they intersect? What are the xy numbers for their intersection? Got to be careful. Thank you, Marieli. Thank you, Heaven. All right. You guys are doing much better than my other class. They got confused because they saw the order. Remember, x goes first. So it's 7-1. All right. Any questions? So this is the substitution method. Okay. So what I'd like to do is do a few more since we're on a roll here. So if you're ready, we'll move on. Okay. Give me a B or a D showing that you're ready to move on because I have to turn my page. I'm filled up here. Okay. I don't see anyone saying, no, wait. Oh, okay. I'll wait a little bit. All right. So in the next few examples, we're going to see where this is easier to work with than graphing, because if you were to do some of the equations we're going to solve by graphing, you would need a whole lot of graph paper. The lines would just be extending really long. Okay. All right. So we're going to move on. So let's see here. This is example 3. And now that we've done a few, I'm going to try to fit a little more on here. So this one, we're going to have y equals 6. And 9x plus 7y equals 33. Now, if we were to graph this, it would be a mess. Really would be. One line would be a horizontal line at 6, yeah, but this other line, oh, it would be difficult to graph. Trust me. Okay, I don't think I'm giving anything away, but y equals 6 is definitely the equation we want to work with. That one already has a variable by itself. The second equation does not have any variable all by itself on one of the equal signs. So we know y equals 6. I'm going to write that down there. Okay, so let's replace 6 for y in our other equation. So I'm going to write it down. 9x plus 7y equals 33. And this 6 is going to go in for y. Okay, so I'm going to rewrite this equation replacing y with 6. Here we go. 9x plus, instead of 7 times y, it's going to be 7 times 6 equals 33. And the reason we do that is we eliminate one of the variables in the equation. I only have x's in this equation. So now let me work that out. 9x stays the same, plus 7 times 6, well, that's 42, equals 33. Okay, just solving it. It's a two-step equation now, guys. It's a two-step equation. I know how to solve those. I would get rid of this 42 with a negative 42. Cancel out. And then I get 9x equals 33 minus 42, or plus negative 42, which is negative 9. Let me divide out this 9 to solve for x. I get x equals negative 9 divided by 9. So what does x equal in this case? X equals what? What's the value for x? Help me out, please. What's negative 9 divided by 9? Yeah, it's negative 1. Remember, a positive divided by a negative is a negative. All right, let's figure out what y is. What is y? Bring down that first equation. What does y equal? 6. That was kind of easy. It was already there to begin with. That's kind of nice. So we got our solution real quickly and easily. Solution was negative 1 comma 6. All right. Any questions? All right. Okay, so we're going to continue solving a few more. So let me move this over. We'll do example 4. 2x plus 2y equals 50. 2x plus 2y equals 50. And y equals 4x. Y equals 4x. So go ahead and write that down, please. And let's identify the equation with a variable by itself. Y is all by itself. We're going to pick that one. It's all by its lonesome. And so I'm going to write it down. Y equals 4x over here. Okay. And I'm going to write down the other equation. 2x plus 2y equals 50. Okay. And I'm going to substitute now. I'm going to take what y equals, 4x, and in the other equation, I'm going to replace, right? I'm going to replace y with 4x. Let me show you what that looks like. 2x plus, not 2 times y, but 2 times 4x. Oh, this is interesting. This is You're changing it up on me, Mr. Contreras. Yes, I am. Yes, I am. Just to keep you on your toes. So now, what am I going to get when I multiply 2 times 4x? Please tell me in the chat. If I multiply 2 times 4x, what does that become? What is 2 times 4x? 8x, of course. There you go. I got this now. 2x plus 8x equals 50. Oh, that's easy. Now we combine the like terms. We got like terms. 2x and 8x. Add those up. If you have 2 and 4 and 8, you get 10. So this is 10x equals 50. Ha. That's easy. Okay. So now let's divide out and figure out what x equals. What does x equal? Please tell me in the chat. Once we finish this up. X equals 5. Thank you. Thank you, Maya. X is 5. Okay. So now take that equation we haven't used, y equals 4x. Take the fact that x is 5. I know that it's 5. But now I want to know what 4 times 5 is, because that's what y is. Y equals 4 times, not x, but what x equals, 5. And that gives me my answer. Y equals, thank you, it's 20. Y equals 20. So now I got my solution. Solution is 5, 20. Okay, and if I were to graph this, this would be kind of a mess because of the equations involved and because of the type of answer I got. Definitely would be messy. Okay, but because I'm solving it algebraically, easier to come up with that answer or find that answer. Okay, all right, we got 2 more left. All right, any questions? Are you guys ready? Now, bear in mind, you're going to have to do this on the assignment. Okay, so be ready. Okay, remember, I do have office hours, so if you're really lost and need more help today at 2:15 to 2:45, or even if it goes over, I can help you. Okay, so all right, let's do it. Let's move on to number 5. And remember, I'll show you at the end of the period how to log on to that Zoom. It's super easy, so you can get extra help. But let's do example 5. Okay, here we go. Negative 6x minus 8y equals 50. And then we have x equals negative 3y. X equals negative 3y. All right, so here we go. First of all, I think I'm not giving anything away. We got a variable by itself in x equals negative 3y. X is by itself. So I'm going to go with that. So I'm going to go ahead and write it down here on the side. And I'm going to recopy my first equation, negative 6x minus 8y equals 50. Because what I want to do is take what x equals, negative 3y, and replace it this time for x. It's going to go in there in place of x. So let me do that substitution step. Negative 6 times negative 3y, and then write the rest of this, minus 8y equals 50. Okay? So I know it looks kind of weird, negative 6 times negative 3y, but it's just a negative times a negative. Yeah. All right. So let's go ahead and multiply. Negative times negative is positive, so that would be positive 18y. So I got 18y minus 8y equals 50. Okay, so now here's the catch. I'm subtracting, right? 18 take away 8, that's 10. All right, and then divide out 10 again. Looks familiar. We did that on the last one, actually. Huh, weird. I kind of do these in my head, dream up some numbers and play around, make it work, and I didn't realize that that kind of would happen. Okay. So I get y equals 5. Y equals 5 in this one. All right. I'm going to bring down this equation, x equals negative 3y. And I want to replace y with 5. I know y equals 5. It's going to go in there. So I get x equals negative 3 times, not y, but 5. So then I multiply that. I get x equals negative 15. And I got my answer for x now. So I got my solution. These two lines, if I were to graph them, would cross at negative 15.5. My solution is negative 15.5. Okay. Any questions? I'll bring that down a little. Okay. We're going to do the last one then. The last one, number 6. Okay. So it's y equals negative 7x minus 30. Y equals negative 7x, take away 30. And then y equals 8x. This is our system. Okay. And we do have both variables by themselves, y here and y there. But y equals 8x is a little easier to work with. So I'm going to pick that one. Okay. And then I'm going to write down y equals 8x. I'll write down the other equation I haven't worked with, y equals negative 7x minus 30. Because what I want to do is replace y with 8x. So in place of y, I'm going to write down 8x in that equation. Let me do that. Okay. So I'm going to say 8x equals negative 7x minus 30. Okay. So now I got an equation, again, where variables are on both sides of the equal sign. So I want to get variables on one side. So I'm going to get rid of this minus 7x with its opposite. The opposite of negative 7x is positive or plus 7x. I'm going to add that to both sides. And I'll combine the 8x and the 7x. That's 15x equals negative 30. I'll bring that down. Okay, so now I have to solve, get rid of that 15 by dividing it out. I'm hoping by now, we've done this so many times, your instinct's good as to when do you multiply, when do you add, when do you do the opposite. It's just kind of becoming more of a second nature. Okay, negative 30 divided by 15. 15 goes into 30 twice, but it's a negative divided by a positive. That's a negative 2. So we got an answer for x. It's negative 2. Okay. So now, boom, 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 boom. I'll bring down my other equation, y equals 8x. I want to replace negative 2 for x. We'll do that in this step. And I get 8 times negative 2, which is negative 16. Okay. And is that all I want? Yes, I'm happy. That's my answer. Yay. I got my solution. Negative 2, comma, negative 16. These two lines would cross at negative 2, negative 16. Okay. All right. Any questions? Any questions at all? Okay. Is everyone got this? Okay. All righty. So are there any questions on the notes? Really? I covered everything? Okay. Then I'm going to stop the recording process, which also we won't be able to view this anymore.